Hello, in this video we're going to look at some examples of finding the domain of algebraic functions and then looking at combinations of algebraic functions. Alright, so our first example, we're finding the domain of f of x equals 5x minus 4. For the most part in algebra, if you're covering this for the for algebra, typically the only functions that you are going to be dealing with that will have any restrictions in their domain are going to be fractions and square roots. There's other functions later on that we will look at, but they typically are not covered at this point. By the time you get there, domain normally isn't as big of a need for review. So that means that if there are no fractions and no square roots, then the domain has no restrictions. I'm going to go ahead and put a star. There's a little bit, there are other functions, but typically at this point you have not dealt with those functions. Those functions include logarithmic functions and other higher level. If there's no square, and then square could be any even root, but typically square root's what we see most often. Alright, so that means if there's no square roots and there's no fractions, then your domain has no restrictions. No restrictions means that the domain is equal to negative infinity to infinity, all real numbers. So our first example, we've got f of x equals 5x minus 4. There's no fractions, there's no square roots, so our domain is all real numbers, negative infinity to infinity. All right, our next example, we've got x minus 7 all over x cubed plus 6x. Well, we've got a fraction. And remember, with a fraction, we cannot have 0 in the denominator. We cannot divide by 0. So that means that we need our denominator to not be equal to 0. So we need to find the x values that we need to throw out here. So we can take a factoring approach here. X cubed plus 6x has a GCF of x. If we factor that out, we're left with x squared plus 6. Set each of those. We want to find where we need to throw it out. So we're going to treat this just like if it were solving. All right, x cannot be equal to 0. Okay, we've got to throw that one out. X squared plus 6 cannot be equal to 0. If you recognize at that step, you can stop there, but if you don't, you keep going. Take the square root of it, move the 6 over, take the square root of both sides, but we are going to get the square root of a negative number, and that's going to be imaginary. So none of the x's that are on the x-axis, none of the x values on our x-axis will give us and make that factor equal to 0. So that means x equals 0 is the only point we've got to throw out. You can put any points that you've got to throw out on the number line and shade everything else, or your interval notation here is going to be negative infinity to 0. We cannot be equal to 0, so we're going to use a parenthesis there. And then we want to put those two pieces together, and the way we do that is we use a union symbol. It looks like some people call it a capital U. It does not have a tail. It is just the U that opens up. There is no tail on the end. And then our other piece, again, is going to start right at 0. We can plug in 0.00001. We just cannot plug in 0. We can get as close to it as we want, but we can't be equal to it. So we're going to use that parenthesis. All right, our next example, we've got f of x equals the square root of the quantity 2x minus 16. So now we have a square root. Remember, with a square root, we cannot have a negative under a square root, so we are going to find the values of x that make what we have underneath that square root greater than or equal to 0. because we can't take a square root of a negative, just like we saw in the last one. It's going to give us an imaginary number. So if we solve that inequality, add 16 to both sides, divide by 2, and we get that x is greater than or equal to 8. So in interval notation, our x is on the left there, so that means that our arrow is telling us which side we're shading. So we're going to shade to the right, and since it can be equal to 8, we are going to use a square bracket or a closed circle. I don't know why I labeled that with an X. That should be an 8. And so our domain is going to be from 8 to infinity. Remember, infinity always has a parenthesis. So that means we can plug in any number, including 8, any number that is greater than or equal to it, and we will get a real number, something that we could graph on the x-axis. All right, our next one, we're putting some stuff together. We have f of x equals 4 divided by the square root of x plus 7. So this one has both a fraction and a square root. So we're going to kind of put the last two examples together. We've got a square root, so that means x plus 7 has to be greater than or equal to 0. Anything that's underneath that square root greater than or equal to 0, so x has to be greater than or equal to -7. But that's also in the denominator, so that means the square root of x plus 7 cannot be equal to 0. If we square both sides, that means x plus 7 cannot be equal to 0, which means x cannot be equal to -7. So if we put these two restrictions together, it has to be greater than or equal to -7, but it can't be equal to. That means that it's got to be strictly greater than -7. So if we put that in interval notation, we get -7 to infinity. All right, now we're looking at a similar problem. We've got f of x equals the square root of x minus 4 all over 3x minus 24. So just like we saw in the last one, what's underneath that square root has to be greater than or equal to 0. So x minus 4 is greater than or equal to 0, which means x has to be greater than or equal to 4. The only time we ever look in the numerator and worry about the numerator of a fraction when we're finding the domain is if we have a square root there. And then we also have a denominator, so that means our denominator cannot be equal to 0. So 3x minus 24 can't be equal to 0. 3x can't be equal to 24. So that means x cannot be equal to 8. So if we look at this on a number line, 4 is the smaller number, so it's going to go on the left. 8's the bigger number, it's going to go on the right. We want the x's that are greater than or equal to 4. I'm going to do this in two different colors. We'll make this one green. So that's going to be square bracket on the 4 to infinity. And then we'll make this one red. X, it cannot be equal to 8, so that means we've got to throw out that 1 point. We'll have an open circle there at 8. So if we put that together on our domain, we're going to have shading. Everything's okay. Square bracket 4 until we get to that 8. We cannot be equal to that 8. We got to throw it out, so we're going to have a parenthesis. We've got two pieces we're going to put together, so we're going to get a union, and then we're going to go from 8 to infinity. All right, so now let's look at combinations of functions. So we're going to do a little more practice with domain, but combinations of functions, the notation f plus g of x, or f minus g, or f times g, all that means is we are going to, it's just a shorthand notation of saying f, and then whatever that operation is of g, or on g. So f plus g means we're going to add f plus g, and then we're going to find its domain. The domain of these functions is going to start with a base domain, which is going to be the overlap of, and I'm going to use a little bit of notation here. I'm going to do a capital D with a lowercase f to mean the domain of f, and a capital D with a lowercase g to mean the domain of G. So the domain is going to be just that overlap unless we introduce a fraction where we can't have 0 in the denominator, because it's okay if G is equal to 0 if we're adding, subtracting, or multiplying by it. We just can't divide by something that's 0. So since we got to find the overlap of the domain of F and the domain of G, let's go ahead and find those first. So our domain of F, we've got a square root here. So our domain of F is going to be 3x is greater than or equal to 0. So that means x has got to be greater than or equal to 0. And then for our G, we have no square roots. We have no fractions. Our G of x here is 7x minus 2. And so we have no restrictions. So that means our domain of G is going to be all real numbers. Well, if x has to be greater than or equal to 0 for one part, has no restrictions on the other one, that means that our domain for our base domain is going to be, and the domain of F plus G is going to be from 0 to infinity. That's going to be the overlap when we overlap x greater than or equal to 0 with negative infinity to infinity. All right, F plus G now is just going to be f of x, square root of 3x, plus g of x, 7x minus 2. We don't have any like terms, so we can't simplify that any, and we're done. F minus g, we're going to do the same thing, but remember when we subtract things, we do need to make sure that we distribute that negative. So when we do the square root of 3x, our f is going to be the square root of 3x. When we subtract that 7x minus 2, we've got to put that in parentheses so we can remember to distribute that negative. It's the most common mistake that I see on these types of problems, because the problems themselves are typically not that difficult. And again, we don't have any like terms, so we can't combine like terms. The domain of this one's going to be the same thing. It's going to be the overlap. So in this case, 0 to infinity. And then f times g, that's where we just have f, g next to each other. In algebra, if we put two letters next to each other, that means we're multiplying them. So f g of x is going to be the square root of 3x multiplied by 7x minus 2. And on this one, there's not a whole lot that we could do. We could distribute that, but in my opinion, doesn't help you a whole lot. I would, if this is for my class, I will take either one of those. Most online homework systems will as well. Again, multiplying is going to be the same thing. The domain of fg is going to be that overlap, which is 0 to infinity. Now the domain for these three functions will always be the same, and it will be the overlap of f and g. All right, this last one, we've got f over g of x, and so we're going to take f of x and divide by g of x, which is going to be the square root of 3x over 7x minus 2. And here we've introduced a fraction. And so this is all that we can do as far as the function itself. That's going to be our function f divided by g of x. Now for the domain on this one, then we cannot have that denominator equal to 0. So 7x minus 2 can't be equal to 0, so 7x can't be equal to 2, which means that x cannot be equal to 2 over 7. So now we're going to start with the domain that we had above, which was 0 to infinity, but we'd have to throw out anything that makes that denominator 0 because it's a fraction. And so when we throw this out, that means that we're going to go from 0 to 2/7 is between 0 and infinity. So we'll throw out that point, and we'll cut it in two places, use parentheses, and have square bracket 0 to 2/7 parenthesis union parenthesis 2/7 to infinity parenthesis. So our domain of f divided by g is that